Let's start with chemistry in this video. The chapter which we are going to cover is Redox reaction part 2. As we have already done in part 1, that what do we mean by redox reaction? We have already studied about the types and the redox and the oxidation reduction concept. That was classical and electronic concept. And we also did few questions related to it. So in this video, we are going to start with part 2 redox reaction. So let's see what we are going to cover in this video, and let's recall that what we have already covered in part 1. So topics which we have already covered in part 1 is the introduction of chemical reaction, types of chemical reaction, intro to redox reaction, concepts of oxidation and reduction, oxidizing and reducing agent. We have done the types of redox reaction. So in this video, we'll start with oxidation state and the applications of redox reaction. So let's start with these topics. So let's start with the topic that what is oxidation number. So see, oxidation number is actually a charge that appears on an atom when all other atoms are removed from it. Let's say if I have a certain complex ion like SO4 2 negative. So on SO4 there is a charge 2 negative. But if I separate the sulfur and oxygen atoms, then they will have a certain kind of charge as X or Y. Can be positive X, can be minus X, can be positive Y, or can be minus Y. So that means that these atoms will have certain different charge, different from their, you can say the net charge, and that charge is regarded as the oxidation state or their oxidation number. So in a similar manner, if I have ammonium ion, the charge on overall ammonium ion is NH4 positive. But if I'll separate nitrogen and hydrogen, the charge on it is not going to be +1. It will something else and can be positive or negative respectively. So these charges which appear on them when they are separated is called as their oxidation number or their oxidation state. So I think you got it, that oxidation number or state is the charge that appears on an atom when all other atoms are removed from it. Similarly, if I talk about the carbonate ion, so it is CO3 2 negative. Overall charge is 2 negative. But when I'll separate them, they will have some other charge, and that will refer to as their oxidation state. Let's take another example. If I have NaCl, it's a neutral molecule. It has no charge on it, right? But when I'll separate them, they will have certain charges. And those charges actually represent their oxidation state or their oxidation number. So let's study more about oxidation number. So now there are certain set of rules that we need to use in order to find the oxidation state of any atom. So let's see that what are the rules that make us or help us to identify the oxidation state. So the first rule is the oxidation number of atoms in the elemental state is taken as 0. So first of all, we have to know that what actually we mean by saying elemental state. Elemental state is a state in which the element usually exists at room temperature. For example, if I talk about hydrogen, it exists as H2. That is, 2 atoms of hydrogen combine to form a single H2 molecule. So this is the elemental state for hydrogen. Similarly, if I talk about sodium, then how it exists? It exists as Na. That is, it is monoatomic. Only one atom exists. It doesn't combine with any other atom or exist. It exists in a monoatomic form. Similarly, let's look for oxygen. Oxygen exists as a diatomic molecule. That is, 2 atoms of oxygen combines to form a single molecule. So this is an elemental state for oxygen. Let's make out for phosphorus. For phosphorus, it is P4. That is, 4 atoms of phosphorus combine to form one molecule of phosphorus. So it is tetraatomic. Similarly, if I talk about sulfur, its elemental state is S8. That is, 8 sulfur atoms combine to form one sulfur molecule. Let's write for Cl. Cl is diatomic, it exists as Cl2. So likewise, these are the elemental states, that how these atoms or any other atoms, how they exist as room temperature. Whether they are monatomic, diatomic, triatomic, polyatomic, or they exist as a single atom, that is monatomic. They can be anything depending upon the nature of atom. It depends or varies from atom to atom. So the first rule is that oxidation number of atoms in their elemental state is taken as 0. So for all these atoms which are existing in the elemental state, their oxidation number is regarded as 0. So this is the oxidation state for any atom which exists in elemental state. Second point is, if there is any monoatomic atom, or you can say there is an ion which has the charge on it. Let's say if I have an atom with the positive charge, we know that atom with the charge is no longer atom, it becomes ion. So if I have Na positive, or if I have Cl negative, or I say if I have Sn2 positive, or Pb2 positive, or Fe3 positive, right, or P3 negative. So these atoms are carrying charge, whether positive or negative, but the charges on them actually represent their oxidation state. Like if it is Fe3 positive, its oxidation state is +3. If it is Sn2 positive, it is +2. It is P3 negative, it is going to be 3 negative. If it is Cl negative, it is going to be negative. So whatever is the charge on the ion, specifies its oxidation state. Third point is, the oxidation number of hydrogen depends upon to which type of element it is combined. It can be combined with metal, that means it can be in combination with metal, or it can be a combination with a non-metal. So depending upon it, the oxidation state of hydrogen is decided. If it is combined with metal, then its oxidation state is in negative magnitude. But if it is combined with non-metal, then its oxidation state is going to be in positive magnitude. So I think you got it, that whenever it is combined with non-metal, it is +1. And when it is combined with metal, it is -1. Do you know that what is the reason behind? The reason is, we know that metals are electropositive. Metals are electropositive and non-metals are electronegative, because they have tendency to gain electrons, and moreover they are smaller in size. And if we talk about metals, they are quite big in size and they have tendency to lose electron. So if we combine hydrogen with metal, so in comparison to a metal, it is much electronegative. That is why its oxidation state is written in negative. But if it is combining with non-metals, it is comparatively electropositive, or you can say less electronegative. So that is the reason its oxidation state is written in positive, that is +1. Another point is, the metals always have oxidation number in positive, and non-metals they have in negative whenever they are present in ionic compound. We know that ionic compound is formed when metal and non-metal combine with each other. And in these compounds, the ionic bond is present. And how the ionic bond is formed? It is formed when metal loses electrons, right? And after losing, it acquires a positive charge. And a non-metal accepts the electron, and after accepting, it acquires the negative charge. So whenever they are present in an ionic compound that is bonded with an ionic bond, then the oxidation state of metal is always in positive, and for non-metal it is always negative. And you need to remember that. Similarly, if I have a compound AlCl3, we know aluminium is metal and chlorine is non-metal. So in this, aluminium is going to have positive oxidation state and chlorine is going to have negative oxidation state. Likewise, if I have, let's say, I have MgCl2 or MgO. So again, metal, non-metal. In this also it is metal, non-metal. So in both the cases, magnesium is going to be positive and chlorine will have negative oxidation state. So this is how you're going to decide, or the rules which you have to follow. Let's look for the more rules. Another rule is, if you have a compound that have two atoms, but those atoms possess different electronegativities. Let's take example. If I have two atoms, they are bonded together to form a compound, but their electronegativity is different. Let's say X is less electronegative, right? That means tendency to attract electron is less and it is comparatively bigger in size. And if we talk about Y, it has more electronegativity and it is comparatively smaller also. So in this case, the one which has less electronegativity, its oxidation state is represented in positive magnitude. And the one with more electronegativity, its oxidation state is represented in negative magnitude. So this is what is written here. That is, in compounds that have two atoms with different electronegativity, the oxidation of more electronegative is taken negative, and for less electronegative, it is taken positive. Let's take an example. Let's say if I have NaCl. We know that Na is and Cl, they both have different electronegativity. That is, Na is electropositive, or you can say with less electronegativity, and Cl has more electronegativity. So Na is going to have the oxidation state in positive and Cl is going to have negative. Similarly, we can have two compounds, like in this case we had metal and non-metal. It can be possible that we have two non-metals. Let's take NH3. In this we have N and H. Both are non-metals, right? So in this case, if we talk about electronegativity, nitrogen has more electronegativity than hydrogen. So in this case, nitrogen is going to possess negative oxidation state in comparison to hydrogen, and its oxidation state for hydrogen is going to be positive. Likewise, we can make for H2O. Both are non-metals, but oxygen has more electronegativity. So in this case, oxygen is going to be negative and hydrogen is going to be positive. So likewise, depending upon their electronegativities, we can make out that out of two non-metals in a compound, which will possess negative oxidation state and which will possess positive oxidation state. Let's take another example. We have OF2, in which oxygen is non-metal. Again, the fluorine is non-metal. But we know that fluorine is the most electronegative element of the periodic table. So obviously, in this case, the oxidation state for fluorine is going to be negative and the oxidation, it is going to be in positive. Otherwise, this is an exception because oxygen is usually possess -2 oxidation state. But here it is combined with fluorine, which is highly electronegative. That is why the oxidation state of oxygen is expressed in positive magnitude in this case. We have another example that if we have a neutral compound. What is neutral compound? Neutral compound is a compound that bears no charge. For example, if I say H2SO4, it is a neutral compound because it is having no net charge on it, neither negative nor positive. But if I write NO3 negative, it is not a neutral compound because NO3 has a negative charge on it. It's not a neutral compound. It's a charged compound. So here we are talking about the neutral compounds. So for example, if we have any neutral compound and we take up the oxidation state for different atoms present in it, so we'll see that the sum of all the oxidation numbers of the atoms present in it can be equated with 0. Let's say we have H2SO4. As you can say, there is no charge. That means it is a neutral compound. Let's say I know the oxidation state of H. Let's write it as X. And for sulfur, let's write for Y. And as for oxygen, let's write Z. So when we will equate these, they will be equated with 0 because there is no net charge on the molecule. Right. So for any neutral compound, the sum of all oxidation number is equal to 0. Let's take another example. If I say I have a molecule NH3, right? So in this case, when we'll write the oxidation state for nitrogen or hydrogen and we add up, we'll be equating with 0 because there is no net charge on it. But if we talk about the complex ions are the ions in which the compound bears certain charge. Like NO3 has a negative charge, right? Like sulfate has a negative charge, or we can say ammonium ion has a positive charge. So these all are complex compounds or ions. So when we will equate or add up the oxidation state for different atoms, they will add up and they will not be equated with 0. They will be equated with the charge which is present on them. Like on sulfate, it is 2 negative. So if sulfur is X, let's say, and oxygen is Y, it will be equated with -2, not with 0. Similarly, if I have nitrogen as X or hydrogen as Y, it will be equated with +1. Similarly, for nitrate, it will be equated with -1. So that means sum of the oxidation state of all the atoms which are present in a compound, and the compound is a complex ion. So when we add up, they are equated with the charge which is present on it. It is not equated with 0. Now let us define the oxidation states in terms of oxidation or reduction, or let's say that we are defining oxidation and reduction in terms of oxidation state. We can say either of it, right? So if we talk about oxidation, what do we mean by oxidation? So in terms of oxidation state, whenever you get to see that there is increase in oxidation number, that means the substance is getting oxidized. The substance is getting oxidized. Let's take an example. Let's say if I have sodium and sodium is losing electron, this is -1, and after losing it is acquiring Na positive. Let's write the oxidation state here. On left hand side, Na is an elemental state. So that means its oxidation state is 0. And on the right hand side, it is positive. And we know that if there is any ion and we want to know its oxidation state, so that is equal to the charge on it. So that means in this case, Na is +1. So if we compare left and right side Na, we see that oxidation state is increased by 1. It is increased by 1. So that means oxidation is taking place. Similarly, let's take another example. Let's say if I have aluminium and oxidation state for aluminium we know is 0. Let's say it is losing 3 electrons and after losing it is acquiring 3 positive. So in this case, the oxidation state is increased by 3. That means it is the process involved is oxidation. Let's say if I have Sn2 positive, that means tin with 2 positive charge, that is it has lost its 2 electron. Let's say it is losing 2 more and after that it forms Sn4 positive. Again, if we compare left and right side tin, we see that the charge is being increased by 2. That means it is undergoing oxidation. So let's take another example. Let's say we have Mg plus H2 and it is forming magnesium hydride, which is MgH2. If we write its oxidation number, for Mg it is 0. For hydrogen it's an elemental state, again 0. Mg is 2 positive, and when hydrogen is combined with metal, we know that it is in -1. Because it is less electronegative. So 0 to 2, that means increase in oxidation number. So that means that it specifies oxidation. So I think you got it, that how on the basis of oxidation state you are going to make out that whether the oxidation or reduction is taking place. Now let's do for reduction. Whenever you get to see the decrease in oxidation number, that means it is reduction. Let's say if we have Cl, if I say that Cl is gaining 1 electron in order to complete its octet and it becomes Cl negative. So here it is oxidation state is 0, but here it is -1 because it is in monoatomic ion. So we know that for it, its oxidation state is equal just as the charge on it. So it is -1. So that means it is decreased from 0 to -1, decreased by 1. And whenever the oxidation state is decreasing, that means it is reduction. Similarly, if I say that for nitrogen it is N And nitrogen usually possesses 2, 5. It needs 3 more electron. So it is accepting 3, and after accepting, it becomes N3 negative. So that means its oxidation state is decreased from 0 to -3. That means it is reduction. Similarly, if I take an example where I have a tin that is 4 positive, that means initially it has lost its 4 electron, but now it's gaining its 2 electron back and forming SN2 positive. So if we compare, its oxidation state is decreasing, and decrease in oxidation state refers to reduction. Similarly, we have one example here. We have ferric ion as Fe3 positive. That means it has lost its 3 electron. Now it's gaining 1 back, and after gaining it is forming 2 positive. So it is decrease in oxidation number. That means the reduction is taking place. And on the similar basis, you can make out that the substance is oxidizing or the reducing agent. Now let's do redox reaction in terms of oxidation number. So let's take one example. In this we have zinc plus HCl forming zinc chloride and H2. Let's write the reaction again. Zn plus HCl forming ZnCl2 plus H2. First step is to write the equation like this in a skeleton form. Now second step is to assign the oxidation number as per rules to them. So for zinc it is elemental state, so it's 0. For HCl, H is positive. We know that it is combined with non-metal and comparatively it is less electronegative, so H will be +1. And chlorine is more electronegative, so it is going to be -1. For zinc it is +2, for chloride it is negative. For hydrogen it is 0 because it is in its elemental state. Now let's compare the oxidation state for zinc. For zinc it is 0 and now it is being increased by 2. So that means the oxidation state is increasing by 2. And increasing, that means oxidation is taking place. Now let's move on to H. Now as you get to see that for oxidation it is +1, but it is decreased from 1 to 0. That is decreased by 1. And decreasing is called as reduction. So that means reduction is taking place in case of hydrogen. Let's move on to chlorine. For chlorine, it is not changing. That means it is not getting reduced or oxidized. So this is what is the oxidation and reduction, and this reaction is called as redox because in it reduction and oxidation both are occurring simultaneously. And if we want to identify the oxidizing and the reducing agent, so here the reduction is being carried by hydrogen, or you can say the hydrogen is reduced, so it is oxidizing agent. In a similar manner, zinc is reducing agent. So by doing this, you can make out that which substance is getting oxidized or which is getting reduced. Now let's see an example that how we calculate the oxidation states. So first, let's say we have to calculate for nitrate ion. So the first step is to separate the nitrogen and the oxygen, or if any other atom is present in a compound, put them in a gap, like place them at certain gap between them. So now let's write their oxidation state as per the rules which we did. So for nitrogen, we know that the oxidation state is going to be -3, right? And for oxygen, it is going to be -2. And overall charge on them is -1. And it is NO3. But I'm not confirmed about N. So what I'm going to do is that in this case, I'll find the oxidation state for N. So let us keep the oxidation state of N as X because it is unknown to me. Or you can say I'm not confirmed about it. So let's add up now. So X is the oxidation state for N, for which we have to calculate. They are different atoms, so we are putting plus sign. Oxygen is -2, 3 atoms, so that means it becomes -6, and it is equated with -1 because the overall sign is -1, and for the complex ions, the sum of the oxidation state of all the atoms is equated with the charge which is present on it. So let's solve for it. So it comes out to be X minus 6 is equal to -1, which further comes out to be X is equal to -1 plus 6, which comes out to be +5. So +5 is the answer for the nitrogen in this case. So let's do for the second. Let's say if we have to calculate the oxidation state for sulfur in this. So first step is to write them with certain gap between them. Let's write the oxidation states. We know that hydrogen is +1, oxygen is -2, and we have to find for this. So assume its oxidation state as X. Now let's add them. So this is +1 into 2, 2 plus X, for which we have to find this thing plus, because sulfur and oxygen are different atoms, -2 into 4, -8, equated with 0 because there is no charge like the NO3 had on the H2SO4. So let's solve. This is 2 plus X minus 8 is equal to 0, or we have X minus 6 is equal to 0, or X is calculated to be +6. So oxidation state for sulfur in H2SO4, that is sulfuric acid, is 6. So this is how you're going to calculate. So I think you got it. Just write the atoms involved with certain gaps, then write the oxidation state. Assume the oxidation state of atom for which the oxidation state is unknown as X. Add every oxidation state for all atoms, and also equate them if there are number of atoms with the oxidation state, and then equate them with the charge present on it, or equate them with 0 if there is no charge. Now let's start with question and answers. First question is that we need to define oxidation number in terms of oxidation and reduction. So what do we mean by oxidation in terms of oxidation number? It is the increase in oxidation number is called as oxidation. Increase in oxidation number is called as oxidation. For example, if Na loses its electron, it forms Na positive. So here its oxidation number is 0, and now it is falling down by 1. So that means it is getting increased. So it is oxidation. Similarly, if we talk about reduction, decrease in oxidation number is called as reduction. For example, if we have Cl, it gains 1 electron and forms Cl negative. So here its oxidation number is 0 and it falls by 1, that is decreases by 1, and decrease in oxidation number is called as reduction. Now let's take up the redox reaction. Let's say if I have Mg plus Cl2 and it is forming MgCl2. So in this case, oxidation state for Mg is 0, for Cl2 is 0 because it is an elemental state. Here Mg is +2 and Cl is -1. So oxidation state of 0 is becoming +2. That means increase in oxidation number. So that means it is oxidation. For Cl it is 0 to -1. That means decrease in oxidation number, which is called as reduction. And this represents the redox reaction. Similarly, we can make out the oxidizing and the reducing agent. The one which undergoes reduction is oxidizing agent, and the one which undergoes oxidation is termed as reducing agent. So likewise, you can define it and you can give few examples in order to explain it in a better way. Another question is, we have to assign the oxidation number to all the species, or we can say all the atoms involved in the formula. So let's do for NaH2PO4. So separate them. Now, for Na we know it is +1. For hydrogen we know it's +1. Phosphorus I have not confirmed, and for oxygen it is -2. So what I'm going to do is I'll be finding the oxidation state for the atom for which I'm not confirmed. Let's assume it as X. So just add +1. It becomes +2. This becomes +X. This becomes -8 equated with 0 because it is a neutral molecule. So this is +3 plus X minus 8 is equal to 0, or X minus 5 is equal to 0, or X is equal to +5. So here I'm confirmed now that phosphorus has +5 oxidation state. Let's calculate for NaHSO4. Let's assign them. Let's separate them. So for Na, I know it's +1. For hydrogen, I know it's +1. For oxygen, I know -2. But for sulfur, I'm not confirmed. So let's assume X. It is +1 plus X minus 8, 0. 2 plus X minus 8, 0. Or X minus 6 is equal to 0. Or X is equal to +6. So in this, sulfur is +6. Let's do for H4P2O7. Let's separate them. For hydrogen, it is +1. For oxygen, it is -2. For phosphorus, I am not confirmed. So let us take as X. So let's add them. 4 plus 2x minus 14 is equal to 0. 2x minus 12 is equal to 0. 2x is equal to 12, or x is equal to 12 by 2, that is plus 6. So now it's confirmed that for P it is plus 6. Let's do similarly for K2MnO4. So let's separate them, write them with little gap. I know potassium is +1, oxygen -2, not confirmed about manganese. So let's take X. This is +2 plus X minus 8 equated with 0. So this is plus X minus 6 is equal to 0, or X is equal to plus 6. So manganese is +6 in it. Similarly, we can do for CaO2. We know that for calcium, it is X, because I'm not confirmed. For oxygen, it is -2. So let's do it. So in this case, it is X minus 4 is equal to 0, or X is equal to plus 4. So likewise, we can calculate. And as you have seen that, like if I take an example of phosphorus, in this case, it comes out to be +6. But otherwise, if I talk about valency, then phosphorus valency is, because its atomic number is 15, if its configuration is 285, so obviously its valency is going to be -3. So like I'm taking this example in order to explain you that valency and oxidation states are never same. They both are different. Valency is combining capacity of an atom, and oxidation number refers to the charge that appears on an atom when all other atoms are removed from it. So don't confuse valency with oxidation number. Another question is, justify the following reaction. That we have to make out that whether it is a redox reaction or not, and if it is redox, then which substance is getting oxidized or reduced. So we know that CuO plus H2, if we'll complete, it will become Cu plus H2O. In this, copper is getting reduced and hydrogen is getting oxidized. So it is a redox reaction. We can actually explain it on the basis of the classical concept, that is addition of oxygen or removal of hydrogen. We can explain it on the basis of oxidation number also. Let's write the oxidation number. In this case, if I make out the oxidation number for it, for Cu it is +2 and for oxygen it is -2. Here we have H2. This is not negative. This is the, you can say the dash for the sign arrow. For it, it is 0. For copper, it is 0. For water, it is +1 and this is -2. So as you can see that its oxidation number is decreasing, +2 to 0. So decrease in oxidation number refers to reduction, and it is increasing by 1, so it refers to oxidation. And similarly, this is reducing agent. We can make this out, and this is an oxidizing agent. Let's complete for this. Fe2O3 plus CO. So it comes out to be Fe plus CO2. So in this, oxygen is being removed from Fe, or you can say here its oxidation number is +3 and here it is 0. So that means it is getting reduced and C is getting oxidized. So this is how you're gonna make out that what following changes are occurring in the reaction. Next question is, write the name of two compounds where oxygen exhibit -4 and +4 oxidation state. So we have to write the names where we need to write the compounds of oxygen exhibiting oxidation state ranging from -4 to +4. So if I write a compound CH4, that is methane, in this the oxidation state is -4. If we talk about ethane, in it the oxidation state is -3. And if we talk about methyl chloride, then its oxidation state in this case is -2. So you can actually calculate them also. And if I write the oxidation state for ethine, then it comes out to be -1. And if I write for CH2Cl2, it comes out to be 0. And if I write for chloroform, it comes out to be +2. And if I write for carbon tetrachloride, it comes out to be +4. So this is how we can learn the compounds, or you can derive the oxidation state for different compounds. Next, we need to write the oxidation state for nitrogen in the following nitrogen oxides. So let's find out for N2O. So this is X. We know this is -2. Let's find out. This is 2X minus 2 is equal to 0. It comes out to be 2X is equal to 2, or X is equal to 2 by 2, that is +1. So in this case, it is +1. Let's find for NO. So X, and this is -2. So X minus 2 is equal to 0, or we can say X is equal to +2. So for this nitrogen, it is +2. Let's find for N2O3. Let's say this is X and this is -2. So this is 2X minus 6 is equal to 0, or 2X is equal to 6, or X is equal to +3. So in this case, this is +3. Let's find for N2O4, X and -2. So this is 2X minus 8 is equal to 0, or 2X is equal to 8, or X is equal to 8 by 2, which comes out to be +4. Next for N2O5, this is X, this is -2. 2X minus 10 is equal to 0, 2X is equal to 10, or X is equal to +5. So this is how you're going to calculate the oxidation state if it is needed or asked in a question to find. Another question is, what is the oxidation state of manganese in K2MnO4? That is potassium permanganate. Let's find out. K2MnO4. So if we find in this, then let's assume the oxidation state for Mn as X, and K is +1 and oxygen is -2. So it comes out to be +2 plus X minus 8 is equal to 0, or X is equal to -6 is equal to 0, and X is calculated to be +6. So in this we have option +6, -6, +2 and -2, and as our answer match with the first option, so first option is the correct option or an answer. Next, we need to write the oxidation state of chlorine in the following. Let's find out. We have Cl2O7. Let's assume as X and as -2. We have 2X minus 14 is equal to 0 because it is a neutral compound. We have 2X is equal to 14, or X is equal to +7. So in first it is +7. Let's find out for ClO3. This is X, this is -2. So X minus 6 is equal to 0, or X is equal to +6. So it is +6. Let's find for this. This is Cl2O, X and -2. 2 into X, 2X, -2 is equal to 0, or 2X is equal to 2, or X is equal to +1. So in this case, it is +1. Let's find for Cl2. Cl2 is the existence of chlorine in its diatomic state, that is elemental state. Its oxidation state is 0. So this is how you're going to find the oxidation state of any element which is asked in the question. Thank you for watching this video, and for more learning experience you can visit www.vosserax.com. So I think you are now familiar with this chapter, that is part 1 and part 2. So if you need more assistance, you can visit www.vosserax.com.